Section 300.4 of the National Electrical Code clarifies the protection requirements for conductors number 4 American wire gauge or larger when they are exposed to severe physical damage. The general rule states that when subject to severe physical damage, conductors must be protected by raceways, boxes, cabinets, other suitable enclosures, or other approved means. Let's break down what this means in practical terms. Firstly, raceways are enclosed channels designed to hold wires and cables, providing physical protection. Common types include electrical metallic tubing, often called EMT, rigid metal conduit or RMC, intermediate metal conduit or IMC, and electrical non-metallic tubing or ENT. Each raceway type offers different levels of protection and is suitable for specific applications. For example, RMC offers the highest level of physical protection and is often used in areas where conductors are likely to be exposed to significant impact or abrasion. EMT, being lighter and easier to install, is suitable for less demanding environments. Secondly, boxes and cabinets are enclosures used to house electrical connections and equipment. They provide protection against physical damage and environmental factors. Junction boxes, pull boxes, and device boxes are common examples. Cabinets are typically larger enclosures used to house panel boards, motor starters, and other control equipment. When used to protect conductors, these boxes and cabinets must be appropriately sized and constructed to withstand the anticipated physical stresses. Thirdly, other suitable enclosures encompass a wide range of protective housings that are not specifically classified as raceways, boxes, or cabinets. These might include custom fabricated enclosures, proprietary cable trays, or other approved means of providing physical protection. The key requirement is that the enclosure must be designed and installed to adequately protect the conductors from the anticipated physical damage. Finally, other approved means refer to methods of protection that are not explicitly listed but are deemed acceptable by the authority having jurisdiction, often called the AHJ. This could include measures such as burying conductors at sufficient depth, providing a concrete encasement, or using specialized cable armor. The acceptability of these methods is contingent on their ability to provide a level of protection equivalent to that afforded by raceways, boxes, or cabinets. Now let's delve into some practical examples of how these protection methods might be applied in different scenarios. Imagine a large feeder conductor, number 4 American wire gauge or larger, running along the exterior wall of a commercial building. In this case, the conductor would be exposed to potential physical damage from vehicles, equipment, or vandalism. To comply with Section 300.4a, the conductor could be installed in rigid metal conduit, providing a robust layer of protection against impact and abrasion. Alternatively, the conductor could be routed through a series of junction boxes and short sections of EMT, ensuring that it is fully enclosed and protected along its entire length. Another scenario might involve a set of conductors running underground to supply power to an outdoor lighting fixture. If the conductors are buried at a shallow depth, they could be vulnerable to damage from digging or other excavation activities. To mitigate this risk, the conductors could be encased in concrete or installed in a rigid non-metallic conduit, such as Schedule 80 polyvinyl chloride, often called PVC. This would provide a physical barrier to protect the conductors from damage. In an industrial setting, conductors might be exposed to corrosive chemicals or extreme temperatures. In such cases, specialized raceways or enclosures made from corrosion-resistant materials, such as stainless steel or fiberglass, may be necessary to ensure adequate protection. Additionally, the conductors themselves might need to be insulated with materials that are resistant to chemical attack or high temperatures. It's important to note that the specific protection requirements for conductors number 4 American wire gauge or larger will vary depending on the specific application and the severity of the physical damage to which they are exposed. The authority having jurisdiction has the final say in determining whether a particular protection method is acceptable. Therefore, it's always a good idea to consult with the AHJ before installing conductors in areas where they may be subject to severe physical damage. In addition to the general requirements of Section 300.4a, there may be other applicable code sections that pertain to the protection of conductors. For example, Section 310.15 addresses the ampacity of conductors and specifies requirements for directing conductors that are installed in raceways or cables. Section 314.17 covers the use of boxes and conduit bodies, including requirements for supporting conductors and making splices. Section 320 addresses armored cable, also known as AC, which is a type of cable that provides a built-in layer of physical protection. Section 330 covers metal-clad cable, often called MC, which is another type of cable that offers enhanced physical protection. Section 334 addresses non-metallic sheet cable, often called NM, which is commonly used in residential wiring. While NM cable is not typically suitable for areas where it is subject to severe physical damage, it can be used in conjunction with other protection methods such as raceways or boxes to provide an acceptable level of protection. When selecting a protection method for conductors number 4 American wire gauge or larger, it's important to consider not only the physical protection requirements but also the electrical characteristics of the conductors and the overall wiring system. Factors such as voltage drop, ampacity, and grounding must be taken into account to ensure that the wiring system is safe and reliable. Voltage drop refers to the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, it's important to select conductors that are appropriately sized for the load they will be carrying. Ampacity refers to the maximum amount of current that a conductor can safely carry without overheating. The ampacity of a conductor is determined by its size, insulation type, and installation conditions. It's important to select conductors that have sufficient ampacity for the load they will be carrying and to dare the conductors if they are installed in raceways or cables with other conductors. Grounding is the process of connecting the non-current carrying metal parts or wiring system to the earth. Grounding helps to protect against electric shock and to provide a path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. It's important to properly ground all metal raceways, boxes, and enclosures to ensure that the wiring system is safe. In summary, Section 300.4 of the National Electrical Code requires that conductors number 4 American wire gauge or larger be protected from severe physical damage by raceways, boxes, cabinets, other suitable enclosures, or other approved means. The specific protection method will depend on the application and the severity of the physical damage to which the conductors are exposed. It's important to consult with the authority having jurisdiction and to consider all applicable code sections when selecting a protection method. By following these guidelines, you can ensure that your wiring systems are safe, reliable, and compliant with the National Electrical Code. Always remember that electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others from harm. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the job. The National Electrical Code is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect changes in technology and best practices. It's important for electricians and other electrical professionals to stay up to date on the latest code requirements to ensure that their work is compliant and safe. The National Fire Protection Association, often called NFPA, publishes the National Electrical Code. The NFPA is a non-profit organization that develops and publishes codes and standards for a wide range of fire and life safety hazards. The NFPA's mission is to reduce the worldwide burden of fire and other hazards and the quality of life by providing and advocating consensus codes and standards, research, training, and education. The National Electrical Code is widely adopted by state and local governments in the United States and is also used as a reference document in many other countries. It is an essential resource for anyone involved in the design, installation, or inspection of electrical wiring systems. Understanding and applying the requirements of the National Electrical Code is crucial for ensuring the safety of people and property. Electrical accidents can cause serious injuries, fires, and even fatalities. By following the code, electricians can help to prevent these accidents and create safer environments for everyone. In addition to the National Electrical Code, There may be other applicable codes and standards that pertain to electrical wiring and equipment. For example, the National Electrical Safety Code, often called NESC, covers the installation and maintenance of electrical power and communication lines. The Occupational Safety and Health Administration, often called OSHA, has regulations that address electrical safety in the workplace. It's important to be aware of all applicable codes and standards and to comply with them. Electrical safety is a shared responsibility. Electricians, building owners, and occupants all have a role to play in ensuring that electrical systems are safe. By working together, we can create a safer world for everyone.